Hi, hello guys. Yes, so today we are going to look at a table in differential equations. Yes, so here we've been presented with series of equations and we are supposed to find the order, the dimension, then we are supposed to tell if the equation is linear or non-linear. Alright, so without wasting much time, let's see how we go about this question. So let's look at question 1, but first you need to know the definitions of these parameters. Good. So here let's look at the order. The order simply is the highest derivative present. So here we have y prime prime, which is 2 simply. So it has been differentiated 2 times, so that becomes our order 2. Let's look at the dimension. The dimension simply we have then it is the number of independent variables, so that becomes x of y or y of x, sorry, and then that gives us 1 as our dimension. Okay, so let's look at the linearity. So an equation is supposed to be linear if the derivative appears to be raised to the first power, or there are no products of dependent variables and their derivatives. So from here, the question, we could see that the equation is simply linear. So let's fill in the table with the values that we had. So for the order was 2. The dimension was 1, which was the dimension of space x, so 1. And then we have it was a linear equation. All right, so let's look at the second question as well. Yes, let's paste this here. Okay, position it well. Okay, so here we are supposed to find the order. The order, as I said, is the highest power of the derivative. So here we have d cubed y. Good. So we could see that the order here is 3 simply. So let's put in 3 there. All right, let's look at the dimension as well. The dimension, right? So we could see that the dimension is the number of independent variable. So we have y of x as our dimension, so simply the dimension is 1. All right, then let's see if the equation is linear or it is not. Good. So here let's rewrite this d over dx all to the power 4. So the 4 there is our degree, right? So this tells us simply that the equation is not linear. Yes, because it is being raised to the power 4, right? So let's put in the values there. So for the order we have 3. We have 3 for the order. So yes, let's come to the dimension. The dimension was just 1. That was y of x. And then for linearity, we could see that the equation was not linear. So this is a non-linear equation because of the degree of the derivative, which was 4. Okay, let's look at the third question. Let's wipe this off. Okay, I think we are good to go. Let's just paste it here, so keep updated. Okay, so we have d squared u over dr squared plus du dr plus u is equal to cos of r plus u. Good. So first we are supposed to find the order. So the order simply is d squared u, so that is 2. That's been differentiated twice, 2, right? So the next thing that we are supposed to find here, we are supposed to find the dimension, and then also for linearity. So we have cos of r plus u, right? So this becomes our dimension. So This tells us simply that it is non-linear. Yes. Why is it non-linear? Because we have um how do you call it, a non-linear function here. So that is our cos of r plus u. Good. So let's look at the linearity, right? So for linearity, it is a non-linear equation. Good. So let's put in the values. So for our order, we have the order to be 2. For the dimension was 1. And then we have for linearity, the equation was a non-linear equation because we had cos of r plus u. Equation. Okay, so I think we are done with this third table. So let's focus on the fourth question. Okay, so we have sine theta of y prime prime minus cos theta of y prime. So simply from this question we could see that the cos, the sign there is the derivative of the cos, right? But we are looking at the order, so that is y prime prime, the highest derivative. So simply it is 2. Okay, let's look at the dimension. So as I said, we could see simply that the sine theta prime prime is the derivative of the cos theta prime prime. So simply for the dimension, we have y of theta. So simply the dimension is 1. Let's look at linearity, right? So we said an equation is supposed to be linear if there are no product of the derivative. Yes, that was 1. So here we could see that the equation is a linear equation here. Yes, so let's put in these values as well to make our table complete. So for the order is 2. That was y prime prime. For our dimension, it was y of theta, the number of independent variable. And then we have for linearity, the equation was a linear equation. Yes, don't forget sometimes you could be asked to find for homogeneity, that is if the equation is homogeneous or it is non-homogeneous. So when it's equated to 0, it becomes a homogeneous equation. Yes, so let's look at the fourth question. Here we are finding only I think 3 parameters, that is the order, the dimension, and the linearity. So let's not go the extra mile. All right, so we are looking at question 4. Let's paste it here and reposition it well. Okay, so here we are supposed to find the order first. So for the order, we simply could see u of tt and then u of xx. So as I said here, the dimension, we have the space which is x, and then the time which is t. So u of xx. So this tells us that our dimension here is space and time. So that is 2. So our order is 2, and then our dimension here is also going to be 2 because we are looking at space and time. So our dimension here is also 2. Now let's look at linearity, right? I said an equation is a linear equation if its derivative and is raised to the first power. So here we could see that this is a linear equation from the equation that we have. It is a linear equation because there are no products of dependent variables as well. So let's put in these values to advance our table. Okay, so for the order we have 2. For our dimension we had 2 as well. That was the space and then the time. Then for the linearity, we could see that the equation is a linear equation. Yes, so let's look at our set equation. Let's make space here. We are looking at question 6. Yes, so let's make space here and then see how we go about that one as well. Let me wipe this off. Okay, so we are good. Let's reposition it well, then analyze it. Good. So for the order in this question, we could see that the order we have x, and then y there. So our order is 2. So we have u of x and then u of y. So our order here is 2. Okay, now let's look at the okay, so we could see that there's a product of dependent variable and its derivative. There is a product, so we could see that this equation is not a linear equation. That's the linearity. So we could say that it is non-linear equation. Good. Let's look at the dimension. The dimension. So here we could see we have x and then y. That is u of x and then u of y. We have space and then so we have 2D as our dimension. So let's put in these answers in the table. So gradually we are coming to the end of the table. I think it's left with only one equation for us to consider, but first off, let's put in the answers that we had here. So for the order, we have the order to be 2. The dimension was 2 as well. 2, and then we could see that it is non-linear equation because we had a product of the derivative non-linear equation. Okay, yes, let's look at the last question, which is question 7. So we are looking at question 7. Let's paste this here to make it easy for us. Okay, so we have u of x plus y of ux plus x of uy plus u of y is equal to 0. So this is a homogeneous equation. But first we are looking at the order. So the order is the highest derivative present. So we have x, and then y. So the order simply is x and then u of y. Yes, our order is 2. Okay, so we are going to look at the dimension, and then we are going to look if it is linear or non-linear. So same way, we have u of xx and then u of y as well. So that is u of xy. So this gives us a dimension of 2. Okay, let's look for linearity. So we could see that the derivatives are only raised to the first power, right? Yes, we don't have any exponential term or any sign term there. So this is a linear equation. With these values, let's put them inside the table. So I think we are at the end of completion of the table. Yes, so we have the order to be 2, the dimension was x and then y, so we have the dimension to be 2 as well. Then the equation is a linear equation. Good. So this is how we go about these type of questions. Yes, so we can find the order, we can find the dimension, we can tell if the equation is linear or non-linear equation. So to be able to do this efficiently, you are supposed to know the definitions for the order, the dimension, to tell if it's linear or non-linear. Yes, so if you have any question, don't hesitate to drop that in the comment section and we will help you with the solution. If you don't understand anything as well, you can let us know. Yes, don't forget to hit that subscribe button and then like this video if it helped you, so you stay updated whenever we upload a new video. Thank you.